Alright, so we can look at covalent bond strength, and bond strength is a measure of how much energy is required to break a bond. So bond strength is listed as the energy required to break a bond, so it's always a positive value. It's called bond enthalpy because it always takes energy to break a bond. So if I look it up on the table, and I think I'd given you a table earlier, 242 kilojoules to break this bond. Always positive, always requires energy to break a bond. Okay? So energy must always be added to break a bond. Okay? All these values therefore are positive. And what you will see if you compare is a C bond. Let me see. I know this one here is 348 kilojoules. Double bond, 614, triple bond, even more. So higher electron density in here causes the bond to be much stronger, pulling this closer together, like 3 bungee cords instead of 2. So multiple bonds are stronger bonds. Now if you look at enthalpies of a reaction, and again P in this reaction, you can look at bonds broken minus bonds formed. Now this gets a little confusing because it's always products minus reactants when we did the change in enthalpy before. What you need to know is bonds breaking always is positive energy, and bonds being formed is always a negative energy. Okay, so in order for this reaction to occur, I need to break the bonds between the Cl and the Cl and the C and the H. And that is endothermic, requires a bunch of energy. But when these come back together, okay, these bonds are formed, that releases energy. And if the net is a greater release, then this is going to be exothermic, right? But bond breaking, first step, always requires energy. Bond formation always releases energy. And you don't know whether it's exothermic or endothermic depending on the difference in the height and where these end up. Okay, but you do know bonds broken, positive, bonds formed is negative, and the net tells you what the change in enthalpy is. Okay?